Hi everyone, and welcome to another part of the Solidity tutorials. In this part we're going to work on a very famous kind of smart contract which is called voting. So voting is going to be a lot useful in so many other kinds of contracts, meaning that, for example, there are a number of people that are chosen as a candidate, and others are going to vote to any one of these candidates. Notice that the kind of voting contract that we're going to work on has no limit for the number of candidates, meaning that you can enter anybody's name and vote. So in the future, we will work on a more specified kind of a voting contract where the candidates are determined, so that you cannot vote to anyone. But in this part, because we're going to get familiar with the mechanism of the smart contract, we try to make our smart contracts as simple as possible. So now let's get started. Here I'm going to create a new file, and I'm going to call this vote.sol, or you can call this simplevotes.sol, because in the future we will have more complex kind of the voting contracts. So simplevote.sol, and just like in the past, we will have the first two lines just the same. There we go. So the license and the version of Solidity. And now, just as always, we will define a new contract, and I'm going to call this voting. So let's open the bracket, and here we're going to have mappings. So this is the first time we're using mapping, and I'm going to first write it and then explain what it is. So address, and then points to the bool, public hasVoted. So as you can see, hasVoted here is a kind of a Boolean variable. So here's the type, this is the type of this variable, and mapping is a kind of mapping, for example, a kind of variable to another. So here, for example, we have the address to the variable hasVoted. So it's, if you have worked on JavaScript, it's like an object, right? In an object, we have a key and a value. So here, in some kind of way, we can say that we want to say that if a specific address has voted or not, then hasVoted is the key and the value is true or false, right, for this specific address. So this is one kind of mapping, and another kind of mapping that we will use in this contract is the mapping of voteCount to the person who has been voted, which is a string here, but in the future we will determine what kind of candidate that person is. So here, just in general, we will consider any person with any kind of name, and for the number of votes we will define kind of a uint number, and so it's public, and the name of variable is voteCount. That's it. So now we'll define a function called vote. Function vote string memory candidate, and then we'll have public. Now let's open up the new bracket, and here we'll have some kind of an if statement, but here in Solidity, as you know, we use require. So here any address will only be will be able to vote only once. So we will use require. If the message.sender has voted, it will show already voted. So here we'll have not has voted, for the message.sender, and message.sender is the person who is voting. And then we will, if that does not hold, then we'll show already voted, meaning that if the person has already voted, then we'll show already voted. So that's it. Now the semicolon. And then if that condition holds, then it will have the vote count of the candidate. Candidate is the string which is related to the specific kind of candidates that we have, the name of the candidate, which is a string here. So the candidate vote count should be incremented, so we'll have plus plus, and then we'll have hasVoted of the message.sender, the person who is voting, will be equal to true, which is a Boolean number. So now I think that's it. We can save this so that it gets compiled. And now, as you can see, it's been compiled successfully. So now let's switch to this section. And now with this address, we can vote for our contract. Now let's deploy our contract. And so let me choose, okay, simple vote.sol. Make sure this is the kind of contract that you have written. And now we have different number of addresses using which we can vote. Now let's head over here, and right now we can vote. Actually here we haven't entered anyone's name, but it's been successful. Okay, let's enter somebody's name, for example Sally, and now let's check our address if it has voted. So as you can see, the result is true, and now we can check the Sally vote count. So let's try one more time, and as you can see, we have voted. So because we have voted before and the vote was empty, there was no name in it, Sally vote hasn't happened here, and now we should vote with somebody else's address. So hasVoted is true for this address, but let's check this address as well. Now I can copy this and paste it right over here. Let's check hasVoted. As you can see, it's false. And so let's vote for Sally. And now let's count the vote. As you can see, it's one vote here. So if here I enter another name or empty, as you can see, because we have voted empty, one vote is for empty vote. And if, for example, here I enter Brian and I count the votes, as you can see, 0 votes are for Brian. So let's choose another account and vote for Sally again. Check Brian's vote here. As you can see, still 0. And let's check Sally. As you can see, there are 2 votes for Sally, and you can vote to anyone because here the candidates are not predetermined. And so as you can see, this is a very simple kind of a smart contract. So I'm going to explain again what happened in this contract. We had mappings. So we had the type of the variables that are going to be mapped on each other. So the address of the candidate of the voter, and also the Boolean variable for checking the status of the user or the voter, whether he or she has voted, and another mapping for the candidate name, which is a string type, and also the vote count of that specific, to actually a mapping from the candidate's name to the vote count of that specific candidate. And as you can see, there is no limitations for the candidates. So if there are two specific candidates, and for that kind of specific circumstances, we should enter another kind of a require, which checks if the candidates are the voter has voted something different than the two candidates, then that person cannot vote, or they will receive a kind of a warning message. But here everything is completely allowed. In real world, it is actually allowed to vote anyone, but the ones related to those specific candidates will only be counted, not the others. But here we can count for anybody else's name. So that's it for this part of our tutorial, and until the next one, goodbye.